In 2019, the first image of a black hole caught by NASA caught the interest and imagination of millions of people worldwide. However, most of these people don't know much in depth about black holes. My name is Arjun Kataria, and I'm going to teach you all about black holes. What is a black hole? A black hole is basically a really dense form of matter that's measured in solar masses. Because of black holes' immense mass, they also have a ton of gravity. In fact, the smallest black hole NASA has found is almost 4 solar masses, which means it has 4 times the sun's gravity. This means that the Earth could orbit something the size of an ant. Black holes form in 4 different sizes: micro black holes, stellar black holes, intermediate black holes, and then supermassive black holes. Micro and stellar black holes generally form when a star dies in a supernova, and then join together or eat other mass to become supermassive black holes. A fun fact about supermassive black holes is that entire galaxies orbit about them, including the Milky Way. The black hole at the center of our galaxy is called Sagittarius A. Now that I've given you a basic understanding of what a black hole is, now I'm going to discuss the exact parts of the black hole. Firstly, we have the singularity. The singularity is basically something that has an infinite property. In the case of black holes, the infinite property is density, according to the classical theory, since there's a finite mass and then squeezed into a zero volume. Next up, we have the event horizon, which is basically an imaginary orbit line around the singularity. If anything went beyond the event horizon, it would have to go faster than the speed of light to escape the singularity's gravity. This is why the event horizon is also known as the point of no return. Next up, we have something called the photon sphere. Photon sphere is basically a sphere of light around the black hole. This light is orbiting the black hole just outside the event horizon. Thus, gravity is not strong enough to pull the light in. I'm sure you guys are wondering, doesn't light not have mass? So how is it affected by gravity? I'll explain that later, but first, let's get to the next part of a black hole that's called the relativistic jet. After a black hole devours some sort of asteroid or other stardust, a fraction of the singularity's meal gets ejected out of the relativistic jet, which is located on the poles of the black hole. Relativistic jets are actually one of the fastest things in the universe. Next up, we have the innermost stable orbit. This is a point where matter and energy can safely orbit the black hole without fear of crossing the event horizon. Finally, we have the accretion disk. The accretion disk is made up of a bunch of superheated matter and energy orbiting the black hole. Now that I've covered the key information on black holes, I'm going to share some fun facts and do some myth busting on incorrect theories. First, I'll tell you how light is affected by black holes' gravity. According to Einstein's theory of relativity, all mass can be technically turned into energy, and the same is true vice versa. Thus, light, which is a form of energy, can be affected by a high enough form of gravity, which is found in black holes. A common black hole myth is that black holes will eventually eat the entire universe. While it is true that black holes' gravity can be felt anywhere in the universe, the greater the distance from a black hole, the weaker the gravity gets. That means that at one point, the gravity will be insignificant. Thank you for listening, and I hope you enjoyed learning about black holes.